What are we looking at today? We are looking at IP addressing. And like I said this is the core because it's the fundamental on which networking is fully based upon. I shared something on the platform earlier in the day where we could see a a a picture of what a network engineer does. So, but as a network engineer, he must understand networking. He must understand Linux. He must understand virtualization. He must have a knowledge of Python. He must have a knowledge of API. That's application programmable interface. He must have a knowledge of the cloud. So this is a way. So network engineer is, putting so many things together. However, irrespective of the career you want to major in, you need to understand how network actually works. You need to understand how network really works. So yesterday we started by defining what is an IP address, right? I've put up questions again on the platform. So we said, what is an IP address? So, Messi, can you tell us what you understand by IP address? What is an IP address? We're listening to you.
An IP address is an identifier that allow um, computer to communicate with each other.
Thank you so much. So, an IP address is an identifier that allows um, computers resources to communicate with each other on the internet or on a network. Okay, just give me a moment. So someone is trying to come in. So let me just permit the person. Just give me a minute, please. Okay. Someone wants to call. Okay, admit. Good. Have I admitted everybody? Okay, admit. All right, so we started by saying what is an IP address, and Miss Messi has just defined an IP address for us. And so I want to share my screen. Just confirm to me that you can see my screen in few minutes. Just so I'll be sharing the entire screen, and so that we won't have to miss anything. However, I might not be able to admit anybody again once I start sharing the screen. So can we see my screen, please?
Yes,
Yes,
sir.
sir. I can see your
Okay, so what are you seeing
screen.
at the moment?
It's just a blank
A blank
space,
space. Good.
white
So,
space.
okay, good. So, um, can you see Cisco? A minute, please. I'm trying to join on my mobile phone so that I can see what you're seeing as well. So, can you see a Cisco packet tracer up here? I want to see if I can make it bigger.
Yes.
Yes, yes.
Okay.
Yes, sir.
All right. Cisco packet tracer. So this, you are going to download this. I'm going to send a link to every one of us. You will download it. This is how we are going to learn networking, how to build a small network. So I shared a diagram on the WhatsApp platform where how a switch connects all other devices on a network. So let's start to build so that we will be explaining what an IP address is from there. So I can pick a switch and I bring it out here. So this is a switch. It's big here. So let me make it smaller so that we can get it there. So I can make it smaller just from the top here. You can see the icon. So this is a switch. Okay, so I come down here, you will see end devices. That is the devices that we call hosts. So we can pick a PC, bring it up, pick a laptop, pick a PC, pick a laptop, pick a PC. Let's just use 5 so devices that want to connect to this switch. Remember that this switch, okay, let's follow the diagram that we have. We call it clients. So how many do we have there? 3 devices. So we can delete this. So if I want to delete this, I come up here. There is a delete icon here. Click on the delete icon, place it on what you want to delete. Do you want to delete laptop 1? You say yes, it goes. Put it on this one again. It say yes, you delete. So we continue that way. So we have deleted that. The next thing on our diagram is a printer. We have a printer there. So let's bring a printer up. So we can bring our printer here. So then we have a server. We won't touch this is a server. We won't touch the internet today. Let's just see how we can connect this. So maybe tomorrow we will work on the internet. But we want to see how all these things can communicate with one another on a network. You are going to set up this. And as you set it up in a virtual environment or in a simulation environment, you can also set it up in a live environment. So you connect to fast Ethernet 0 on the PC. So let's connect this one to Ethernet 1. So the same thing you do to laptop, Ethernet 2, you do to PC 1, Ethernet 3, fast Ethernet 3, then to the printer. Let's put our printer 2 on a unique interface. Let's say we put it on 10 and we put our server on 11, port 11. So let's give it name based on the IP address we want to give them. So let's say 192.168.10. Let's say this one is 21. So PC1 or this first PC is .21. Then let's call this one 192.168.10.22. Okay. Then let's say this PC3, we can actually double click on this and copy it so that it's easier for us. So we said this will be 23. So let's give this printer a unique IP. Let's say .10, 10.10, and our server, let's give it 10.200. Okay? Are we still here, please?
Yes, sir.
Okay. So now the only way through which these things can talk to one another is through their IP addresses. The only means through which they can talk. Okay, somebody is raising up the hand. Please go ahead. What's your question? Ask your question, please.
Sir, how are you getting the IP address?
Okay, thank you. How am I getting the IP address? So I am just forming this IP address for now. As time goes on, we'll begin to see how we are getting the IP address. IP address are different classes. We've not gotten to that. I will explain. So for now, just understand that we have IP address, and to understand that the only means through which these things can talk to themselves is through the IP address. Okay, so I'm not getting IP address from anywhere now. I just use an arbitrary IP. But remember that this IP, the first octet, we're explaining something yesterday, but I will start from the first octet. When you see an IP address, it contains this is broken into 4 distinct layers. That's 4 octets. Octet 1, 2, 3, and 4. And this is in binary, or is in binary at the moment. That's why we gave that assignment of binary and binary. We will get there. But just know that IP address is used for communication. I want us to just test how this communication really works and how they can talk to themselves on a network. So this is an example of a LAN. This example of a LAN network. Do we understand that? But don't worry, you will begin to get how we come about IP address as we move on. So,
Okay, sir. Thank
all
you,
right.
sir.
Hello, sir.
Okay, please go ahead.
I think I thought about this too. That it looks like a LAN network, more like what is it called? The less expensive one where where cables are connected to the switch to supply other systems. Am
Exactly.
I correct, sir?
You are very correct. This is a LAN. This is office setup. Like if you want to set up in your office now, just maybe between 20 people or 30 people, and this is just a LAN setup. That's why you see that there's not even a router here. You are not even going to the internet yet. You just want to be able to communicate with one another. You want to be able to send documents to one another. You want to be able to print. That's what we will try now, and you will see how it works. So this is your computer. On this computer, when you open it up, this is the way it looks. So you see to configure, you see desktop. On this desktop, you see IP configuration. This is where we can configure our IP. So we said that this first PC is what? 192.168.10.21. And automatically your subnet mask will pop up 255.255.255.0. Somebody raise up the hand. Okay, please ask your question.
Sorry, sir, just an observation. We are not recording this session,
I'm recording it.
or is it anything?
It's recorded.
It's not. Okay, sir. Thank you.
Yeah, let me see. Let me just confirm that again. Show in my screen. Yes, it's being recorded. Okay.
Okay, sir.
So 192.168.10.21. Your subnet mask will automatically populate. Don't worry about subnet mask now. We're going to deal with that later on. And don't worry about gateway yet. You only need a gateway if you want to begin to move from one network to another. But if you are within a network, you don't need a gateway. Just know that one. Gateway is your router. Is the IP that is sitting on your router. But don't worry, we're going to look at all of that. So you just need to be able to communicate within your network. So all you need is an IP address and a subnet mask. Okay, so you see IPv4 address and not IPv6. So we've configured the first system. So let's move to the second system. You see the diagram is like a laptop, just the way the laptop looks like. So you come to desktop the same way. This one is .22, and your subnet mask will automatically populate because it's a class C subnet. We close this again. We go and configure the third PC IP address, and we said this is .23. And when you click on the subnet mask, automatically it populates. So we have configured the 3 devices now. So let's see if these devices can talk to one another, right? So how do I know? I told us about something called ping the other time. Ping is an internet protocol. Internet protocol. So when you open this command prompt and you do ipconfig, I put it on the platform, ipconfig. ipconfig is for you to confirm what is the IP address of your system. ipconfig is used to confirm, I put it on the platform, is used to confirm the IP address that is on your system. So you will see that the IP address here is what? 192.168.10.21. Okay? So, is anyone raising up hands? Let me see. No. Okay. So good. Now, can I ping .22? So if I ping 192.168.10.22, is it responding? Can you see? It's responding. So you see that it says packet sent 4, packet received 4, lost is a 0% loss. In other words, there is reachability. Is able to reach .22. Okay, so let's see if it can reach .23. Okay, so I put 23. So it can also reach .23. Now, if I ping .10, which is our printer, will it be able to reach it? I want somebody to respond to that. If I ping .10, which is our printer, will it be able to reach it? I need a response.
No, sir, I don't think so.
Why?
Because you've not connected it to the switch yet.
I've connected the printer. See, cable has been connected. I'm expecting something. I've connected it, but I have not configured an IP on the printer. Do you get? We've
Yes, sir.
we've only configured this PC, and this one. We are yet to configure the printer. So if I try to ping the printer now, that is .11, right? Or .10. If I do .10 now, you will see that it's going to be doing request timeout. You see, request timeout. It's not able to reach the printer because there is no any IP on the printer. I don't know if we understand what I'm saying here. So it is only IP that you can use to communicate. Even though you have a cable connected, it does not mean there will be communication. So now let's try to configure this printer now and see. So I go to the printer, you go to the interface. Okay? On the interface, we say static. So it's giving us this. Hold on, there is a place to configure our printer. Okay, so you go to fast Ethernet 0, which is the interface. So we said this will be dot 10, right? And the subnet mark automatically populates. Now, if we go back to that PC, and print and ping again, will it work?
Yes, sir.
Why?
Yes, sir, it will work because you've
This is configured.
connected the printer to an IP.
Thank you. We've configured the printer with an IP. So if I do dot 10 now, can you see there is a response? And it tells us, if you look at the first response we got here, it said packet sent 4, packet received is 0, lost 4, 100% loss. But now, packet sent 4, received 4, lost 0, 0% loss. So we are able to reach our printer. Do we understand what is happening now? So this is a simple network. We are able to reach the printer. Once you can ping a device, once you can ping a host. So the most important thing is you are going to be talking in terms, in terminologies. So when you say host, no say I can print I can ping the printer. I can ping that particular host. You are talking in terms of uh terminologies that are being used in networking. So now we have our printer reachable on the network now. So if you come to this second PC now and try to ping the printer again, ping 192.168.10.10. You see, it's responding. So everybody are able to talk with one another on this network. Now, let me even do something interesting here. So let's give this switch a name. You see, they are calling it switch 0 here. You can give it a name by just coming here and give it, instead of switch 0, let's call it Network Kings switch. So once you do that, definitely the name will change. You can see it, Network Kings switch. So maybe we should move our printer up. You can decide to move the whole design this way, so I can make it smaller, move the whole design down again. But because of our learning, I will still make it a bit bold so that we could see. So, all right, just give me a minute. I'm trying to make it better. So you can just navigate, and there are things you begin to also learn as you are working with the packet tracer. There are some things, so you might need to do more even than just coming to class. So let's have our 3 PCs here. I just wanted us to see that the name of the switch has been changed to networking switch. So let's say all the 3 devices are here and our printer is here. Okay, I'm trying to see if you have a question, you can drop it on the chat box or you can raise your hand too. So we said it's a LAN network or a LAN topology or a LAN setup. So we have our server on dot 200 and the printer is on dot 10. So let's just put this way. Now, I said I wanted to test something for us. So in this switch, on our switch, if I come to this switch, don't worry about whatever you see me type now. If I say show MAC address table. Now, on the MAC address table, you will see only 3 things are here. Fast Ethernet 1, 2, and 10. Who can tell me why it is only Fast Ethernet 1, 2, and 10 that is here? Just think. Meanwhile, if you do show IP interface brief, you will see all the interfaces that we got connected to the switch. We connect fast Ethernet 1, 2, 3, and we connect 10, 11. But now, when we are checking the MAC address table, we only saw only 3 MAC addresses, which is for fast Ethernet 0, fast Ethernet 0/1, 0/2, and 10. Anybody have an idea? We are learning. So you should ask questions if you don't understand some things. And if you don't know, you just say, okay, I don't know. So I explain. Okay. All right. If you discover all this while, we only have 3 things opened. Our PC1, right? Which is on fast Ethernet 0/1. Then PC2, fast Ethernet 0/2. And our printer on fast Ethernet 10. Now, you have done a ping from PC1 to PC2 and a ping from PC1 to the printer. So the only 3 places he has learned something is on the fast Ethernet 0/1, 2, and 10. He has not learned anything from 3. He has not learned anything from 11. As a matter of fact, we've not even configured any IP on this server. Do you understand what we are saying here? Hello?
Yes, sir.
Okay, good. Thank you. So we understand what an IP address is now. That an IP address enables us to be able to communicate with different hosts on a network. Let me ping .23 now on this, or from PC23. Let me ping now, and you will see what will happen. So if I do IP config here, I know that this is .23 now. Let me ping the printer from here, 10.192.168.10.10. Now I'm able to print the printer. If I go back to the switch and check my MAC address table again, so now you will see that he has learned fast Ethernet 0/3 now. And he has learned the 10 as well. So he's able to learn. Now, if I go and do a continuous ping, let me do a continuous ping. You will see this how to do a continuous ping. I'm going to teach us, don't worry. So to do a continuous ping here, you do ping -t. So it should continue to ping .23. That's on our PC1, the first PC. So let me copy the command, or let me type it on our chat box. I don't want to leave this so that what we will see is just this in our ping -t, then the IP address 192.168.10.20 or .10. So that's the command to ping continuously. So on PC1, I'm pinging continuously. Let's move to PC2. Let's ping as well continuously here. So there's a continuous ping from PC2. Let's do the same thing on PC3. Also continuous ping on PC3. So the 3 devices are pinging the printer continuously. So let's check on our switch now. You see, it's now learning all the MAC address on those interface. So it's learning from fast Ethernet 0/3 fast Ethernet 0/1, fast Ethernet 0/2. The same thing happens if you bring up another PC now on that on this network. So this MAC address is unique. Okay, somebody is okay. Thank you. So this MAC address is unique to each of the devices on the network. So we are saying that it is through IP address that a device can communicate to one another on a network. Let's even do some little design and something fancy tonight. Let's pick a PDU. PDU is just a message. So let's carry the message and try to send a message from PC1 to the printer. What's the destination? What's our printer? 10.10, right? 192.168.10.10. That's the destination IP. And our source IP is .21, which is where source is where you are pinging from. Okay? And destination is where you are pinging to, where you are going. So sequence, let's say 10, and then time, let's say 10. So we do create PDU. If you look down here on the, you will see successful. Are we still here?
Yes, sir.
Okay, so you see successful telling you that you have successfully sent a packet from PC1 to the printer. Now, if I want to see a failure on this, all I need to do is to pick an IP that is not in the range of that subnet. Now, what type of message do we send? We send an ICMP message. But don't worry, we'll look at all of that as time goes on. So I want to agree, or I want to assume that we all understand what an IP address is now. Or do we have anybody that still needs explanation regarding IP address? Do we understand what an IP address does on a network now? So if you agree, just go to the chat box and say, yes, I understand IP address. And we move to the next question. Okay, yes, sir. Okay, I've gotten the first response. So once I get like 3 or 4, move on. Okay. All right, so let's move to the second question. What's the second question? Can somebody read for us? The second question says what? What is the difference between IPv4 and IPv6? Who is going to explain that for us? Anybody? If you are the one that explained it yesterday, I won't want you to do that today, okay? Because we are doing a recap and I want people who were not in class yesterday should explain this for us. So, what's the difference between IPv4 and IPv6? So, Stephen, can you explain to us what do you understand that, what do you know is the difference between IPv4 and IPv6? Okay, I've gotten another response. Fine. Stephen, can you explain what is the difference between IPv4 and IPv6? All right, Israel, can we hear you? Oh, somebody said network is frustrating him. Okay, sorry. So sorry. All right. Stephen, Israel, are you there?
Yes, sir.
Okay, so what's the difference between IPv4 and IPv6 from your study?
I, IPv6 supports more more data than IPv4.
Okay, IPv6 support more users, okay, than IPv4. That's one.
Yes,
Good.
yes, more users.
Yes.
Yes,
Okay, fantastic. All right, so IPv6, it's the fear that, oh, IPv4 might be exhausted. So we came up with the IPv6 protocol. So, and we explained yesterday that IPv6 has, you will see it now when we open. Let me show you now on our, we can stop this now. So on our interface here, when we're configuring the IP, you see IPv4 here. And down here, you see IPv6. So you can see the way IPv6 is written. Now, IPv4 is written in decimal, and is subdivided into octet, 8 bits per each octet. But IPv6 is in hexadecimal. Hexadecimal is base 16. Okay? So IPv6 is written in hexadecimal, base 16. So that's why you can see it FE, 80 and semicolon, on and on like that. So very long. It look weird. Even some networks, they've not started using IPv6. Most of the time where I see IPv6 really in use is in abroad networks. So, but it's already in use to some extent. But the fear and the reason for IPv6 is the fear of, oh, IPv4 might be exhausted. Okay. But through the technology of NAT, there's something we call NAT, network address translation. We are rest assured that, oh, okay, IPv4 can still serve our purpose. So, what am I saying? IPv6 and IPv4, they are both internet protocol. But what we'll be focusing more attention on is the IPv4. It's like somebody is raising up their hand. Is there anybody? Okay, nobody. So we move to the next question. What's the next question? We said, how is an IP address structured? Yes, this is where we got our assignment from yesterday. How is an IP address structured? So let me bring up my notepad, and so that we'll look at what we did yesterday, and from there we can take a bearing tonight, and we will understand. I know that some people didn't submit assignment because they didn't understand what was done, and they don't want to stress themselves. It's understandable. So, how is an IP address structured? Anybody want to answer that? How is an IP address structured?
Yeah, good evening, sir.
Good evening.
We said yesterday that an IP address is a series of numbers used to identify a device on the network. And those series of numbers are usually in four, and they are divided into octets, like octet 1, 2, 3, and 4. And the numbers that are being used always ranges from 0 to 255, and they are called dotted decimal notations.
Oh, thank you so much. Fantastic. So IP address are structured in octets. So if you see something like 192.168.200.20, you already know that this is an IP, an IPv4, not just even IP now. You must begin to talk in tech form. This is an IPv4 address. You can see 10.10.20. 5 or 4 is an IPv4 address. So it doesn't matter whether it's 7 or 10, whichever range it is written. So far, it's in 4 octets. We are saying it's an IP address. And that leads us to say, okay, we know that our computer only talks in what? Computer talks only in what? In binary, which is base 2. Computer talks only in binary, which is base 2. So how does this computer understand 192, 168, 200, 20? So there is need for us to now convert to base 10. So because this is base 10, all the 192 are in base 10. So we need to convert it to base 2 for the computer to be able to do it. So there is what we call compiler. We have interpreter that does all of those conversion for us. So we must understand that this 192 we are seeing here is actually a series of 1010101010. It's a series of either 1 and 0. So that's why we did that conversion yesterday of how to convert from binary to decimal and from decimal to binary. And from what everybody submitted, I think everybody did fantastically well. So we'll not be dwelling on that again tonight, but we might have to visit it as time goes on. So for instance, when you are looking at 192 now, let's try to see how we convert 192 to binary. Let me see if I can use my is anyone raising up hand? No. So sticky notes. Just give me a minute. Let's see. I want to use the board. Wow. So let me stop presenting and then so I can use the board. So we have about 15 minutes more, but don't worry, we will working on something. Okay, so if you can see my screen, please let me know. Can you see my screen, please? Can you see my screen? Hello? 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 Oh, if you can see my screen, please let me know. Hello? I was muted. I'm sorry.
Yes, we can see it, sir.
Okay. So we are trying to see how to convert. I'm looking at a background that is Bit cleaner. Okay, so let's use this. So we want to learn how to convert. That we are saying we started with simple ones. So let's look at our assignment. Let's even do our assignment and see. We said convert the following base 10 to binary. And the first one was what? Was 25. So we pick 25. We want to convert 25 to what? To binary. And we said this will be what? Raised to power 0 and raised to power. Is that true? No.
No.
So if we want to
To be
convert,
divided by
we divide by
divided by
2
two.
or by, yes. So you have 5,
Yes.
2, 5,
It's-
and then we rule this way. And we say, how many times can we have 2 go in 25? That will be what?
12.
12, remainder
Remainder 1.
1,
1.
and 2 goes in 12, will be 6,
6 remainder 0.
remainder 0. Thank you. So let's do it together. Okay.
3 remainder 0.
Okay.
1 remainder 1.
1, remainder 1. Thank you. Then we said this will be what? We say 0, and we move this
0
this
remainder
1
1.
outside. Thank you. And we are going to go this route. That is, when we are writing it,
Yes.
the arrow goes up. So 25 base 10 to binary. 25 base 10 to binary will be equals to 1 1 0 0 1 base 2. Do we understand this?
Yes.
Yes, sir.
All right. So now that we've gotten this part clear, so let's move to the second one. I will leave the second one for us to be. I believe that with that we can solve 80. So let's solve that of 1000 because I want us to do 192 tonight, and then we move to the next question. So 1000, when we want to convert 1000 now in binary to base to denary, that's to base 10. We say this will be raised to power 0, 1, 2, and 3. And that means we are multiplying it by 2. 1 times 2 raised to power 3 plus 0 times 2 raised to power 2 plus
2.
0 times 2 raised to power 1
1.
plus 0 times 2 raised to power 0.
It's by 0.
And this one will be anything multiplied by 0 is 0. So all this one has become 0. Remember that 2 raised to power 0 is 1. Please note that. Because there are some times that you will be giving 1 here. So that will be 1 times 1 here. Don't go and conclude that 2 raised to power 0 is 0. So remember that in your laws of indices. So this one will now be 1 times 2 raised to power 3, which is what? 8. So if your answer is equal to 8 here, correct. So 1000 base 2 to base 8. Do we understand that? Hello?
Yes, sir.
Okay. So I expect us to be able to solve our what's it called now? Our remaining assignments. For those of us that haven't done the assignment, we should be able to fix and resolve that. So the next question says, What are public and private IP address? What are public and private IP address? What are public and private IP address? Someone want to help me? What do you understand by public and private IP? So we have what we call public IP. Who is answering that question for us? What is a public IP and what is a private IP?
Yes, sir.
Okay, please go ahead.
Uh, a public IP address is assigned to a device or a network by an internet provider, maybe ISP.
Okay,
But it is visible to the outside world and it's used to communicate with other devices on the internet.
okay.
While private IP address is used within a private network, like such as home and office. It is not visible to the outside world, but also it is also used to communicate between devices on the same network, that is, on the same private IP addresses.
Do you know if I was to give money, I'm supposed to give you big money. Fantastic. That is it. A public IP address is always given by a service provider, an internet service provider. So, why a private IP is what is used within a network, within a LAN. Like all the 192 you see me using, all this while is a private IP. Do we understand that? Now, look at this. On our shared screen, you will see it 192.168.10. These are private IP that is used within a local area network. So a private IP is used within a local area network, while a public IP is used for an ISP, is given by an ISP, and it is what you use to access the internet. You use a public IP to access the internet, unlike private IP that is mainly used for communication within a local network. Do we understand that? I want to share something with
Yes,
us.
sir.
I'm going to show us something in a minute, but I'm trying to set up the second meeting, because this meeting is going to end in 5 minutes. So private IP is used within a LAN, while public IP is used for accessing internet over a network. Over so uh, I've shared the link, the new link on our chat box now. So we'll join in 5 minutes. So let me quickly explain something here. If you go to your phone now and do what is my IP? What is my IP? What you will see is your public IP. And you will also see your provider. Okay, let me stop sharing and share my screen again. So there's something that you should be able to see here. So once you can see my screen, please let me know. Can you see my screen, please?
Yes, sir.
Okay. So look at me now. I'm going to my browser. What is my IP? See my question. It's very simple. What is my IP? And I click enter. Did you see this? He said what? Your somebody should read it for me.
Your public IP address.
Is 102.89.46.134. You see that it's telling me where my public IP is. That is what my public IP is. That is the IP that is helping me to access the internet. I can do further research about that IP. You see now, it tells me what my IP address, IPv4, is checking for IPv6. He said IPv6 not detected. It means then who is my ISP? Can you see? MTN Nigeria. Can you see that now? So, what is my IP? This is my public IP. But I can also now check my private IP if I do command prompt. So you can just press the window key on your laptop, the window, and R, it will come up with command prompt. You now do CMD and press enter. When you press enter, the command prompt will come up. So CMD command prompt should come up. Now that my command prompt is up, I can do IP config. Here now, it's going to show me my private IP. Are you seeing this? 192.168.192.9. This is my private IP address. Do we understand the difference between public and private IP now? Hello? Hello? Hello?
Not very well, sir.
Okay. All right. Let's join with the second link now. Okay.
Okay.
All right.
All right.
Can we hear me, please? Can we hear me? Hello?
Yes, sir.
All right.
Yeah, we're here.
Okay. So,
Yes, sir.
public IP is the IP that grants you access to the internet over a wide area network. Fantastic. I think this is the best way to explain it. over a wide area network. Where is Mr. Toby? He's the one that said he didn't really understand them. So when you want to leave your normal, when you want to leave your LAN and move to one, you want to be able to access resources over the internet. That is where you need a public IP. But when you want to talk within your local area network, all you need is a local IP. So all you need is your private IP if you are to talk within your LAN subnet. So that is, but as we continue to learn, you will begin to understand their differences. So private IP are used within a local network, while public IP are used for public or internet facing. And another thing is that public IP are not free. You have to pay for them. That's why you said an ISP are the one that gives or provide public IP. So you will pay and they will give you the public IP. So, and you'll be able to use them. So there are people who are in charge of that. We call them Afrinic. We call them Afrinic and some other names like that. And so that is that about that. Let's move to the next question. Or do anyone has any question before we move on again? We need to answer at least 3 more questions. So let's move to the next question if you don't have any question again. How do DHCP, Dynamic Host Configuration Protocol Server, assign IP address? Does anyone want to explain this? Because I want to show us something now, and we will configure a DHCP server tonight, and then we call it a day. I think that's what I will just do for us tonight. We configure a DHCP server and we call it a day tonight. Are we ready? Hello? Who wants to explain DHCP server to us? What is DHCP server? And how does it assign IP address? Nobody can explain that for us? Paul, what is DHCP server? What do you understand by DHCP server?
Um, so I think that it is a dynamic host configuration protocol. It
Okay.
assigns IP address dynamically to the host.
Okay. So I want to say, okay, yeah, I'm listening. Yeah, Paul, you wanted to say something?
Yeah, I said it assigns.
Yes, I heard you, Miss Genevieve. I heard you. So let's call this LAN setup with IP address, with static IP. So I want to close this and do a new one now, whereby we want to do a DHCP server. Okay? So let's look at this together. Let's bring up 3 of. Let's bring up 4 devices. Let all the devices connect to a switch and the switch connects to a router. We will now use that router as our DHCP server. Please, we are. So now, remember when we were configuring the other time, we assigned IP, right, statically to these devices. But now, we want a device to assign the IP automatically. We don't want to assign any IP statically to these devices. Now, who can tell me one of the reasons why we don't want to assign IP statically? Somebody should tell me. Or what are the benefits of using a DHCP server? That's another way of saying it.
So obviously it will save time, and it is with this, unlike the initial one when we were doing it statically, we there was possibility for errors, probably not properly configuring it. So
You,
it
you,
saves times and it erases possibilities of error. I don't know how to put it well.
you have done fantastically well. Number one, it's going to save you time. Imagine if you have 200 users. You now be going
It
to
make network troubleshooting easier.
Thank you. It makes troubleshooting very easy. You have to be going each person 200. You'll be tired. Then when you have configured like 20, there is possibility that when you want to type 192.168.20.10, you now go and type 192.168.2.10. And what will happen? That one will not be able to talk on the network because it's not on the right subnet. Do we understand what we are saying here? So let's say that our router is 192. It should be the gateway 192.168. Let's say 200.1. That's the router. So let's say we want this guy. We don't even know the IP we want to give this guy. But let's say it's user 1. User 1. Okay? When we are done, we will know the IP that he will have. And let's say this guy is user 2. And this is user 3. This is user 4. It saves time. It gives little or no room for error. So all we need to configure is this router communicating. Once we configure the router interface, we are good to go. So this one, no, don't worry. I will teach us this. So let's say the host name. So the first thing we will configure here is the host name, config T. Host name of this router, let's call it Network Kings IT solution. So we have changed the host name. So the most important thing we want to configure here is this interface. Let's look at the interface. It's G0/0. So interface gigabit 0/0. We say IP address is 192.168.200.1. And the subnet one is 255.255.255.0. No short. Once we say no short, that interface will come up. Can you see that the interface is becoming green now? Okay. we've configured, the interface is becoming green. What it means is now it can carry traffic. So let's configure our DHCP server. So we need to look at that together. IP DHCP. So let's see. First thing we need to do is to check how do I even configure a DHCP server. When you do config T, configure terminal, that's configure terminal. We're going to do all of this. So DHCP, when you type DHCP, it's not giving us anything regarding DHCP here. So we can do exit and do DHCP. So if we didn't get anything regarding that, we can do IP DHCP. If it doesn't give us, then we go back to our config terminal again, IP DHCP. So we can see it here now. So this is where we can configure our DHCP. So to configure DHCP is IP DHCP. So now you need to do exclude. If you want to exclude, you want to remove some IP that, for instance, the IP of your router should be excluded from the IP that should be assigned to this PC. The IP of your printer should be excluded because you need that printer to have a static IP so that everybody can be able to map to it. We'll look at all of that later. So exclude IP. So you say IP DHCP, exclude which address? The address will be 192.168.200.1 to 10. So it's not allowing us to do that. So you can just say .1 and the high one 192.168.200.10. So you don't want it to assign any IP from 1 to 10. Okay, you see that it doesn't throw any error here now. So when we are assigning IP now, it will start assigning IP from 11 upward. Do we understand that? Do you have any question? Please ask.
Yes, sir.
Do we understand that? All of us, do we understand that? So what we are saying is that it should not assign any IP from 192.168.200.1 to 192.168.200.10. So from this 1 to 10, you can give to your switch, you can give to your printer, you can bring to your server. Okay, so let's configure the pool now. IP DHCP pool now. Pool. We give it a name. What name? Let's call it Network Kings. Network Kings DHCP pool. So we've given it a name. Now you will see that the command have changed from to DHCP. So the next thing you can use question mark to see what's your default router. Your default router is your gateway, which is 192.168.200.1. That's the router. Okay. Now your network. What is the network? 192.168.200.0. That is the network. It says incomplete, so you need to apply the subnet mask 255.255.255.0. So it has taken that. What other things? DNS. You can put your DNS. DNS. We will look at DNS later. You can say it's 8.8.8. So we have configured then WR to save. You have saved your configuration here. Now, if I come to this router and do show run, I want to see what is running on it. If you look at it, can you see now? We've configured host name. We've configured IP DHCP exclude this IP. Then the DHCP pool is Network King DHCP pool. And the network is this network. And the default router is this .200.1. And the DNS is 8.8.8. So now, let's come to this PC. Are you seeing this? Can you see my screen, please?
Yes, sir.
Yes, sir.
Now, when
Yes,
I
sir.
come here, instead of saying static now, I will click What? Somebody should tell me. I will click DHCP.
DHCP.
So when I
DHCP.
did you see this now? Can you see? DHCP request what?
Yes, sir.
Can you see?
Successful.
DHCP request is what? Successful. And what IP did you
Successful.
give it? Somebody should call it for me. If you are seeing my screen. What IP did the first PC get now?
192.168. 192.168. 200. 11.
Dot 11. Thank you. Can you see that the subnet mask what? 255.255.0 and gateway 192.168.200.1 and the DNS 888. Did you see that I did not manually put this IP? He got that IP what? Via the DHCP server.
Self.
Did you get that? So from here, I will be able to
Yes, sir.
ping the router now without configuring any static IP. Can you see? I'm able to ping the router successfully. Any question? Do we have any question? So let's go to the second PC. On the second PC, you see that there is no any IP now, right? If I try to ping, that's how to test something. Let me ping 192.168.200.1. Somebody should tell me what will happen. Will I be able to ping it?
It will fail. It won't go
It, no,
through.
it will fail. It won't go through.
Why? Why?
Because no IP has been assigned.
You've
Thank
not
you.
gone to
Yes, no IP address. You have not, he hasn't gotten any IP address, whether static IP or via DHCP. So no any IP address yet. So, but if I come now and I come back to the configuration and I say, okay, I need you to get an IP via what? DHCP. Is requesting for an IP now. What happened? It
that's
has
popped up.
gotten an IP 200 dot what? 12. You see, he's assigning
Right.
it one after the other. He has assigned dot 11 to the first one. He will never make mistake to go and assign dot 11 to PC1 and go and assign that same dot 11 to PC2. No. It will be assigning it logically one after the other. So you cannot have an error. So if we try to ping now, let's start the ping again. What happened? He is what? Successful. So do we understand what a DHCP server is now and how it works?
Yes, sir.
Okay. So our major work will be to install a Cisco packet tracer tomorrow and carry out these two designs that we've done. Okay? Any question? Any question? It's almost 11 p.m. So I want us to close for the day so that some of us are still going to work tomorrow and nights. So I know some people are enjoying the class, but we need to also rest.
Hello, sir.
Okay, please ask your question.
Hello, sir.
Yeah, I can hear you.
Sorry, this Cisco packet tracer that we are using to do the configuration, the pinging and all, is it a software or something?
It's a software, yes. It's a software.
That means we have to download it.
Yes, I will send the link to the platform. We'll download it. And tomorrow we'll be able to rest.
Okay.
Maybe Saturday we can have a class. Tomorrow we'll be able to rest, and then you can begin to do some troubleshooting and how to set up your own. So we have rest tomorrow and maybe Saturday. Because I want us to, I don't want us to rush, but then we shouldn't be sitting back because there's so much to learn. And the earlier the better for us. The earlier the better. Okay. So any question why we call it a day today? Any question? We spent an hour, 20 minutes already. Any question? Okay, so if there's no question, thank you everyone for coming to class and do have a wonderful night. Bye.
Thank you, sir. Thank you, sir.
Yes, you're welcome.
Thank you, sir.
You're welcome.